Let me just start. Hi, welcome to this Open Security Summit on the CDR API Standards. And CDR means Content Disarm and Reconstruction, which is one of the technologies that a number of companies, including Glasswall, works at. And what we basically want to do at this session is just talk about some of the new implementations that we've been working on, and also some kind of standard that is starting to emerge. And the idea here is to think about, can these standards that we have basically be evolved into something that is not just in this case Menlo specific or Glasswall or OpSWAT or other implementations, but almost like a CDR, Content Disarm and Reconstruction standard, which is basically a way to send files and get files back in a safe state. So I think we've got a couple of good representations here from Glasswall. We did send some invitations out. They might join in a bit, but we actually have two Pauls here with us. We got Paul Farrington and Paul Burke. Paul Farrington leads our product. Paul Burke leads our customer success engagements. And I'll just give a quick intro, and then we can kind of go into the sort of the meat of the conversation. So the first step of this was that we've done, at Glasswall, we've done a couple of integrations with other tools. One of them was Garrison, which also has this sort of remote browsing capability. And fundamentally, what we wanted was to figure out a way to integrate with those tools. So when we were basically start working with a customer that actually integrated with Menlo, and Menlo is a tool that allows you to remote browse websites, they have a problem of how to download the files. So when we look around, we basically found that OpSWAT has already done a good implementation of this. Again, this is open source. So and OpSWAT did a great job here. They kind of followed, I think, the Menlo documentation on how to implement it. OpSWAT, again, provided a good, I think here it is, right? A good sort of description. And then when we look at implementing this, we say, look, might as well reuse this because this is already a good standard. It might actually do the trick for us. So when we've implemented this, we actually, actually started with their code, but then we evolved it a little bit. Again, our code is open source. So again, we're contributing back and we make it easy for our customers to integrate this. And we kind of come up with this sort of API that has this sort of endpoints to send data in and out of a CDR platform. But fundamentally, it's kind of interesting and is more generic than that, because what we want is a situation that the same way that we have our ICAP integration, where we can work with any proxy that or tool that supports ICAP, we almost want to have a mode where once we define and ideally as an industry we can agree right on this sort of CDR API that anybody integrates with it, then they can basically just clock into whatever CDR tool they're using. And it's important to note that for some more I would say advanced or in terms of customers who really are looking for the extra level of security, the recommendation is actually that you put two of these tools in sequence. So you don't just use one tool, you actually put it in sequence. And we actually have cases where our technology is already part of a pipeline that has other sort of CDR vendors in there, right? So again, it's good to have a common set of APIs that can be used by whoever's calling, whoever's instrumenting the workflow. They can basically just call it like that. So Paul B, I think we were talking about this before. Do you want to add a couple more comments, and then we can delve a bit into the API and see what it looks like?
Oh, the thing we touched on is why are we interested in talking about this kind of approach, is because this is going to help customers with adoption is the primary reason why, which is what you touched on, right? And whilst we see value in doing that, it only works if we can interest the rest of the industry in adhering to a standard to make life easier for customers. And the intent of this session is the first, hopefully, of a longer conversation to make that happen.
Yep, I agree. Paul F, you want to add any comments too?
No, I think you captured it. I think you captured it. Be interested to see what colleagues on the call think of that suggestion. It in principle makes sense, I'm sure. But is there a motivation for us to start to kind of coalesce and move towards that standard? That'd be good to understand. And
yeah, because one of the calls we had last year, where we also had some good participation from some of the other members of the CDR platform. One of the things that we were talking about was also create a set of files that are standard files that people can use to do evaluations, people can use to testing, because it's a nation industry, right? It's not very easy at the moment to sometimes think about, if I'm integrating this, what should I think about and what should I do? And again, that's something that we try to make it easy, we try to make it understandable, and also how, for example, it works from an API point of view, like what's the outcome of this, and ideally this would then be rewritten to even just API, because this would be a generic in and out, right, of what is the workflows that you'll see when you have an integration with this. So we can go a little bit into the current way this is implemented, because I think it's relevant as a health check, and then of course please chip in with the questions, or if you want to make any further comments, right? Providing. So the first one we got is the health, right? So this is basically an API that you call, and it's an interesting one, where it was kind of one of the first ones that we found some ambiguity on the implementations, because the original, if I believe, OPSWAT implementation, we're actually telling you the health of the integration, where we actually try to give the health of the actual end-to-end solution. So this is already one where it would be quite good to have a good definition here of when you call the health, like what do you get, right? And actually what we're also finding is important now to start to have things like even some of the version numbers, even some other information. So this is a good one where you probably don't just want, in and out sort of, paths in, you kind of want, a lot more definition on actually what actually happens here, right? So the inbound is basically is a check where you can basically make a call, and then you check that if the file has been processed or not. So this is a method where you can say, what is the status? Have you seen this file before, right? So actually, maybe I start from here, right? So the first thing you do is you actually send a file, right? So this is the submission file, where you actually provide information about and you can see in this case, this came a bit from some of this information gets provided by Menlo in this case, and it's also a good example of something that at the moment is hard coded to this particular implementation, where I would argue that one of the things that we want to think about here is that we have other use cases. We have use cases where the data from the API is going to come from a file system, it's going to come from an S3 bucket, it's going to come from a proxy, right? Or or a website. And in some of those cases you might see like some of these data, others you don't. So I think we probably need to think about some of the use cases where some of these metadata is also provided maybe as an extensive set, so that we can also extend it, but we can make sure that we implement it in a scalable way. The kind of most important part here is actually the SHA-256, because that allows you to do a lot of understanding of actually what the file is coming, and also actually an interesting question mark that you have here is, for example, the file name. In a lot of cases, we have situations where we actually don't want the file name to go through, right? Because the file name actually contains sensitive information, and sometimes you want that, sometimes you don't want that. So you want to take that into account. And the file type is also an interesting one, because one of the interesting situations you have with CDR is that one of the unique features of CDR is that it's one of the best technologies to determine the file type. But actually what we found is sometimes we have to be careful, because, for example, like you don't want a proxy making decisions based on the file type, based on, for example, on extension or MIME type. So one of the metrics that we actually sometimes capture is comparing, for example, the original file type with the final file type compared by the engine, because that's a good example of also some kind of malicious activity. So here you can see that in a way, if you want to make this a CDR sort of standard, right, it's important to start to cover other scenarios, or it's important to think about from a metadata point of view, right? How do we make this extensible, and what bits we want to kind of make sure we hard code the name so then it's consistent, but what other areas will give some flexibility, right, on how that's implemented. Any comments on this?
Do you actually send the file?
Yeah, so the file is, so basically we receive the file, the CDR engine or CDR API receives the file to be basically transformed into a safe file.
Makes sense. No, but I was thinking about the like having a bucket or something, like you don't share the actual file, just share pointer to that place, so you don't just send the data over to every place.
Well, so that's an interesting challenge, right? Because for example, like, remember that the entity processing the file, in fact, for example, in one of our cases is actually completely isolated, right? Like in a way that we almost sandbox that to say that, we're going to use one pod per file, and you almost at that level when they receive the file as a binary string, right? So, like if you look at the proxy situation, the proxy is the one that authenticated the user and knows how to get the file in the original state, right? So yeah, I think in this case, we always need to start with the actual file, because that's what we're going to process on. But this could be an HTML file, it could be a PDF, could be, a docx file, could be an MP3, etc.
There is there is some file size limitations, right? You don't want to scan ISOs or DVDs or, I don't know, 30 gigabytes of raw data.
Yeah, I think it depends then on the definition of what you're rebuilding, right? So we actually handle gigabytes of data, right? So we actually, we can do it. Look, I guess it's an interesting question, right? Like in a way, the logic here is that we want to make a file safe. So for example, like if there's a way to exploit an ISO, right? If there's a way to create malicious ISOs, there's an argument to be said that we should be processing, right? At the moment, I think our use cases are more about, here's a bunch of business documents, here's a bunch of web traffic, can you make that secure? But we, at least with our latest version, right, we will scale as long as there's memory and processor, right, to handle it. I think the engine can go up to a key, a bit more, and some of those things are actually more depending on the horsepower of the machine that you're running versus a physical limitation, right, of the technology.
Definitely.
But you can see here that, so the SHA one is an interesting one, because there's an argument to be said that you can cache some of this, right? So you might want to have a workflow where you first say, have you seen this file before? If you have, do you have it already ready for me, right? And if you don't have seen it before, right, then you send the file through, right?
Yep.
And yeah, so any other comments? Like for example, what would be a good way to create that metadata and map that metadata on this?
The metadata for the file?
It's no water.
Yeah, whatever gets you.
It's no problem. Just me open. It's okay, yeah.
Cool. Yeah, sorry about that, guys.
Okay, bye-bye.
Yeah. So basically, if you look at this, right? So from an API design, right? This API, it's a bit, is a little bit hard coded to the idea that the file comes from a request, right? So if you look at a client IP, user ID, some of that stuff, right? So this is a bit hard coded to the use case of a proxy, right? Or you're browsing a website. But the use case for processing a file is kind of wider than that, right? So I guess my question here in terms of the pattern to do this, right? do we want to have on the submission, you send all the metadata? Should you have other endpoints to say, send more metadata? But again, we want to make it as simple as possible to the entity that's processing this, right? So you probably want to have one request that has the data, right? That then, triggers the process for how it works.
Yeah, definitely.
Cool. All right. So then the thing that happens with this, right, is on the API is that then you got this sort of check. So this is designed, and I think it's a good pattern, is designed to be done in an asynchronous way. So the idea would be that you send the file through, then you come back at regular intervals, right, to make sure that you got the file, which is also an interesting question, whether the solution should not also handle synchronous calls, right? So when you got, for example, on the ICAP server, it works quite well when it's synchronous, because the ICAP server makes a call and then it has a timeout to say, I'm going to wait for that, with that connection open. It's okay to leave the connection open because by definition, the ICAP server left it open, and then come back and get it. So I think it's interesting to take into account the two modes of operation here, where you can either have an asynchronous call, which is what you have here, or you have an asynchronous one where you send the file and you get the response, eventually, which will work for files that take, from half a second to 10, 20, 30 seconds, but won't work for much bigger files. In fact, there's probably an interesting question, which do you want to support the mix mode, where if we can get the file done in, let's say 2 or 3 seconds, we return the file straight away. If, it's going to take longer, we just return the ID so that you can then call this function here with, in this case, with the SHA-256 of the file, which basically tells you, what is the status of the file being done. And this is the kind of conversations that I think we should be having kind of nowish, right? Because it's we're still at the point where we get to define the APIs, but if this becomes widely used, then it becomes harder to change the API at later stage, right? So and what we can do is we could also create a version that is compatible with this, but it starts to augment it, right? To basically have that capability. Okay, so then once you get the check, you're going to get a response, right? In here, and then eventually you're basically going to call, the result allows you to get an information. You can see here you got pending, outcome, report, etc. Actually, so I think I made a mistake. I think this one is check if the report already exists. So this is basically a call where you send the SHA-256 for the file, and then you basically saying, have we seen it before or not, right? And then and this is the one that you actually called to get the results. So this is the one where you pass unique identifier, and then you get a status. Depends on this. And this is another good example of, we really want to make sure that we come up with a good list of status that matches the wide set of use cases for the CDR industry. Because, for example, at the moment, one of the limitations we found with Menlo is that you don't have, it's either infected or clean or not good. And I think we want to make sure these outcomes here, we can have a nice list of options there, right? In terms of what you respond. And then the logic is that once we got that done, you then make a call to this, and this is the call that then gives you the file processed, so then you can continue in their journey. So that's the end flow. So if you look at the end flow, is you send the file, you get an ID, you check if the file exists. So in fact, actually the workflow is you check if the file exists already. If it is, you go and get the flow. If you don't, you send a file through, you get an ID, then you actually implement it. And in fact, I think we actually have some, we got some workflows here, right? That kind of describe that.
Dinis, the better workflow would be in Menlo security. If you look at the Menlo file processing, that gives the whole end-to-end, just below that, this one,
Yeah, that one, cool. Yeah, so that's basically the workflow here, right? So basically you see that you check the hash. If it is, you send that. If you get an existing file, you actually can go all the way to go there. If not, you actually send a file, you go post emailed, that gives you a job ID, right? Then you submit the file, then you get information, and then you check here if the file is being completed. Once it is, you actually, and this is now becomes, a little bit of, again, Menlo specific, because Menlo has an option to replace or not the file. If this option is done, then you're actually going to get the replacement file, and then you retrieve the file that actually overwrites the original. So again, like, but the workflow is that sort of asynchronous workflow where you submit the file, and then you get an ID, then you come back at the regular intervals to check it. Which it's kind of it's interesting because it depends a little bit now on how real time you want this to be, right? So if you care about responses in 200 and 500 milliseconds, you might want to get a mode which is a little bit different. If you can wait a couple of seconds or a couple of processes for the downloads, then the checks. So if there's longer pools, because some files on some cases might take 30 seconds, a minute, right? Depends on the complexity, depends on the size. And there's also actually an interesting phase of even, at high volumes, just sending the data across might hit some limitations, right? So there's other interesting variables at play here. Cool. So any comments or ideas or kind of what we can, and the next steps of this and how we can evolve this?
I saw that the hash is optional.
Yep.
Because if not, I know that the UID points to the operation, not the file, but you have like two different identifiers there.
Yeah, so there's a difference. So in an interesting way, right? Like we actually calculate the hash also, right? From where we get the file, right? So I think the hash is useful from a point of view of saying, have you seen this file before? Like, have you seen the file with this hash before, right? But we will actually internally, we actually calculate the hash of the file, and we actually use it again as one of our IDs, but we give an ID of the almost a transaction, which is the one that then gets checked here, right? So basically, when you do this is a unique identifier for that file that was submitted. Yeah.
I think the hash becomes important because more enterprises want to do event correlation, and the hash is the easiest way to compare, what we find with the file to what does their AV stack say, or what does their sandbox say, or what another CDR say, right? It's a common reference point across different systems.
Yeah. And I guess the interesting question there becomes a case where, you want to cache anything on a server side, right? Where then the hash will be enough. Where you want to use the hash as a unique identifier across the whole transaction, but then that means that multiple transactions might have the same hash, right? It almost feels that in some of these cases you almost want to, you might want to send both, or I can see value in using the hash, like you said, Paul, to track things end to end, but you probably lose a little bit on the transaction ID. In fact, what I think would be also useful here would be for the caller to provide its own tracking ID. Does that make sense, Paul? See what I mean? Like imagine here also receiving an ID, right? That is actually so not just of the user, but also like a file ID or a transaction ID or something that can then be used to correlate the logs to the original source. So you can have an end-to-end across the organization flow, which is actually what Amazon does with some of their tracking.
Yeah, because I think the challenge we've got with hashes is we change them. So when we process the file, there's at least two hashes, and if we process a file with different policy on removing active content, there can be more than that. Yeah,
that's absolutely right. Because because the hash of the resulting file is going to be different, but also the result that we do, it depends on the policy of that particular file, right? And then if then look in the future in terms of even other transformation like redact and other things, right? There's a question of saying, let's make sure that, for example, from a cache point of view, it doesn't introduce certain problems, right?
Yeah, or at least there's a way of tying all those references together, so you can then
Yeah.
see the full journey history of any file.
Yeah, I have to say, I quite like actually this idea, thinking about it, of actually passing a unique reference. Sorry, passing a reference that is given to the platform from the caller, because so we start to use some log correlation, and actually one of the things you do with log correlation, for example, Jagger, right, what it's called, and others, right, and even some of the ways we correlate some of the data in Elastic, is you kind of need a glue, right? You need a unique ID across the board. So I think as we move, across, so even here, right, as you move between systems, right? So if you look at, the workflow of this, i.e., it would be quite good to have an ID that is given by the endpoint that gets persisted across every one of these entities, right?
Yeah, you can use a timestamp there, right?
Sorry?
You can use a timestamp, an initial
Yeah.
timestamp, and a hash, of course, right? You just
Yeah, the
hash timestamp and IPs and whatnot, and that will give you a unique ID.
Yeah, but I'm saying is that you want to propagate it, right? Like
Yeah, you propagate it.
So
Yeah,
you want,
but
yeah, go on.
yeah, you just take a picture on the timestamp and the source IP, hash of the file and whatnot, and then you get a unique number that you can propagate. It's like Nginx's request ID or similar.
Yeah, but that's generated at the gate, right? Like, so the gate here,
Yeah, exactly.
whoever at the gate can have a job of creating an ID that then, almost every element in the chain, right, will basically at least log it, right? At least, be able to provide even.
Yeah, you need to trace it that way. Yeah,
yeah. For your billions of events, right? How do you, how do you take the thing? And we, basically, the idea of this is to process millions of files, right? The idea is to process, if any, billions of files, right? Like the idea is to, for example, on a proxy, right? Especially on high volumes, right? Eventually, you're going to see a huge amount of traffic flying through these things, right? And then that correlation becomes super important, right? Cool. Any other sort of comments on the API, on other areas we should be thinking in terms of adding things here?
What about the need for things like a monitoring call that says if any file gets dropped in a folder, process it? But
that would be a different service, right? So I think like we're approaching it, right? Like I think that would be, as the service that calls this, right? That is responsible for.
Yeah, I mean, it's almost like that. When you talk about database interaction, there was 3GLs and 4GLs, and is that a 4GL thing? Is that an advanced thing? But I think the more we can simplify some of those things, the more it might help.
Yeah. Yeah, so look, I view this as a little bit as the actually, as kind of the sort of like if this then that, right? I feel that what you end up having, come on guys, give me a nice picture, right? Is basically something that you've got this integration, right? That you got lots of implementations, right? It's kind of like you want something like this, right? If what's it called? If this trigger, then that. So the kind of the that in some of these parts here is that, if somebody puts a file on Slack, then sends a file to Glassfall CDR, or sorry, CDR platform, right? So any integration, right, that exists here, right? And then vice versa, right? So, and again, in here, you can actually have a say, send it to Glassfall, sends it to OpsWat, sends it to others, right? Send it to AVs, right? There's could be all sorts of other interesting integrations, right? And each one of those does one thing, like, and then you can say, well, if the file has not been processed by the CDR engine, then send it to a sandboxing engine, right? So I think it's a case where we want to then make it super easy for these connectors, right, to be built, knowing that once you add the little bit of knowing how to consume from, from one of the multiple integration points that these guys have, then what's it called? Then it's easy because you get the rest, right? And that's kind of what you want, right? You want a world like this, right, where you pick, you pick a particular, what's it called? Integration source, right? And then once you've done that, you can then say, by the way, here's now the CDR API, and as long as that bit is done, then you get the workflow. And you can actually build some of the workflows, for example, they were talking about on top of this, right? And we've done integrations where, we have a Lambda function that listens to an S3 bucket, right? And once that gets through, then that sends the file to the API to be processed. So again, it would be good to have a generic open source version of that, right? Because this is where the use cases and integrations become quite interesting, right? Because you just need to then build one piece of the puzzle, and then you access a whole bunch of other stuff on top of it. Cool. Well, so basically, maybe just wrapping this up a little bit, right? So the logic, what we kind of feel the next step to this is start to actually break this into a kind of an open source project that, again, multiple people can collaborate. And let's do another session in a month or 2 months from now where we can get a couple of other players from the CDR world to be involved, and then we kind of move the needle forward, and we start to try to define a standard that we can all use, and and test files that we can all use, and a nice way to define, again, we had already sessions in the past on Open Security Summit, right, about multiple standards and multiple ways that you can measure it, and how to slice that. So I think it's about continuing this conversation. So cool. So any final thoughts? No, we wrap the session up. All right, I think we're good. Then see you next time.